Hi, hello everyone. So this is the video dealing with topic 7.5, which is dividing radical expressions. And we call it rationalizing the denominator. And the reason for this name for rationalizing the denominator is because sometimes it's not possible to divide radical expression. So a division of radical expression is a division where, as you see here, this is one such example, where the denominator is a radical value. Now that it may be possible, it may not be possible to simplify the radical expression. So in the cases where it is possible to simplify, we divide. If it is not possible, like in this case, we then have a different method to simplify the expression. So we don't normally call it division of radical expressions. We call it rationalization of the denominator. So we're going to see two types of cases where we are going to rationalize the denominator. We're going to see cases where the denominator is going to have a single term. These will be these three cases we're going to see here, examples 20.3, 4, and 5. And then we're going to see cases where the denominator has two terms. And we'll see these other cases here. Okay, the cases where the denominator has a single term are easier. So let's begin with that first case. The idea is, like in example problem 20.1, there's not much that we can do here with this radical. We cannot simplify the radical. So then we are going to use the technique of multiplying both numerator and denominator by the radical. So this is a common technique. And the reason for this technique is that once we do that with the denominator, we'll get the index of the radical cancel with the exponent of the radicand, so that the radical disappears. So this is the purpose of division or simplification of the radical in the denominator, calling the process rationalization of the denominator, because now the number is a rational number and the division makes sense. I'm dividing whatever this number is into 13 parts. So this is our goal here, okay? And it doesn't really matter if we have more complicated radicals in the denominator. So let's take a look and we'll see the examples I have here. 20.3 is the first one. So here is one such case. The question is either going to read rationalize the denominator or divide or simplify. Either one of these three terms you can expect. And I'm going to write simplify here, because in that sense, when you have the question, you are supposed to know that this is division. And in this case, there's not much I can do to divide. For example, such as in this case, what if I had this? This case, I can certainly simplify radical 4, and this will be over 2. So this division is complete. I'm done. Be very careful not to simplify these two with that 2, because this 2 is outside of the radical. This isn't. So in this case, I cannot do that. I cannot simplify radical 7. So the technique is you are going to multiply numerator and denominator by the denominator, whatever it is, radical 7. And now look what happens. In here, I have basic multiplication of radicals. I get radical 49. Numerator, I get radical 14. Nothing I can really do with radical 14, so it stays the same. But what is radical 49? 7. And this is my final answer. Notice that we really didn't divide anything. The division didn't take place because we don't know what radical 14 is. It's an irrational number, but we left it in a form that is rationalized, meaning what? Meaning that the denominator is a rational number. Rational number. And this is the process of rationalization. In this case, we left it in division format, but we didn't really perform the division. So that's why sometimes we don't call it division of radicals, we just call it rationalization process. So this is the first example. Take a look at the second one, 20.4, radical 4 over 5. Over 5. So in the first step of this problem, we would break the radical into 2, radical 4, radical 5. And before you even do anything, you realize that this is simplifiable. So you turn the problem into 2 over radical 5, which is where we should start. You look at the denominator, there's nothing that you can simplify, so you employ the technique of multiplying numerator and denominator by the radical denominator, just as before. There's an invisible 1 here if you want, because now we are going to have to multiply these two numbers. The 2 is going to multiply the 1, and we will attach the radical 5. Remember, the 2 does not multiply the 5 because 5 is inside of the radical. The 2 is not. So invisible 1 here, 1 times 1, 1, radical 5 times radical 5, radical 25. And now this is going to be simplifiable. This is my final answer. Do not simplify these two 5s because this 5 in the denominator is outside of the radical. So the operation stops here and we cannot divide further. So therefore the name rationalization of the denominator. Okay, good. Third example, 20.5. And it doesn't really matter if we have numbers like in 20.3, 4, or a variable in 20.5. So this is 3 over radical x. The procedure is done the exact same thing. 3, is it 3 or is it radical 3? 3 over radical x. Three over radical x. Okay, same as before. All right, we have to turn this into a rational number. And in order to do that, we are going to multiply numerator and denominator by the radical denominator. So in the numerator, I have 3 radical x, as we've seen before. And in here, we have radical x squared. And we've seen it before. Since this number, the index matches the exponent, they cancel each other out. And we are left with this, which is our final answer. And just as in the previous example, this x does not simplify with that because the denominator is outside of the radical, the numerator isn't. So this is my final answer for that particular problem. Okay, so these are the cases dealing with a single term as your denominator. So this is the first case. The second case is when we have something like problem 20.7, where we have 2 terms for my denominator. It doesn't really matter if I have one radical or two radicals. The procedure is going to be the same. We are going to do a special type of multiplication involving what we call the conjugate of the denominator. So the conjugate is the same two terms, but with the opposite sign in the middle. So if I have, for example, a plus b, the conjugate would be a minus b. If my term is a minus b, the conjugate would be a plus b. Same two terms, but opposite sides in the middle. Okay, so let's take a look in this case. I have to rationalize the denominator, and this is my denominator. I have two terms, so this is the technique involving multiplication by the conjugate. Every time I have two terms, multiplication by the conjugate. So my denominator is 3 minus radical 2. The conjugate that I'm going to use is the same two terms, but 3 plus radical 2. So the multiplication happens the same way as it did before, as we saw in the previous video. And at the end, if possible, we'll simplify. So look at 20.8. I have to rationalize this denominator. My denominator has two terms. Now I have to apply the conjugate method, which I have to first find what the conjugate of 7 plus radical 3 is. But the conjugate is the same two terms, but the minus in the middle. So I'm going to multiply numerator and denominator by 7 minus radical 3. Okay, at the end, after the multiplication is done, I will try to simplify if possible. And the answer is this. And notice, at the very end of all of these problems where we rationalize the denominator must be a whole number at the end. The whole process is going to require us to get rid of any radicals in the denominator. Okay? Whether I have two terms or whether I have one term, as in these cases. At the end, there will be no radicals in the denominator. Okay, so let's take a look. So let's do 20.10 first. 20.10, 3 over 11 plus radical 7. Okay. Make sure that we copy this right. 3 over 11 plus radical 7. And I see that I have two terms. So the technique is the conjugate. The conjugate of 11 plus radical 7 is 11 minus radical 7. This is what I'm going to do. Make sure that you remember there are invisible parentheses around. And now my multiplication is done. Just as we did before in the previous video, this is going to multiply the 11. The 3 is going to multiply to 1 radical 7. And for the denominator, we are going to apply the FOIL method, right? Because I have two terms and two terms over here. So 11 times 11. 11 times minus radical 7. Plus radical 7 times 11. And something's going to happen here that you may have noticed already. Positive radical 7 minus radical 7. The reason we use this technique of the conjugate is because of the following. Once you've multiplied by the conjugate, the two middle terms will always cancel. Always. This is always going to happen unless if you made a mistake somewhere. So I have 33 numerator minus 3 radical 7. This is 121. This is minus 7. Okay. 33 minus 3 radical 7. And then 121 minus 7, 114. Okay, we would see that if we can simplify, but for now, this is okay, and I'm done. And I hope I will bring up an example where there is a common problem that students make here, and I don't want anybody to make, so I'm going to make sure that I mention it to you. If we don't see in one of these problems in the workbook, I will give you one for us to see. So 20.13. 20.13. These are all similar problems to 20.10. You can try them at the end. 20.13, now I have two radicals here, which is fine. The procedure is exactly the same. So 11 over radical 6 minus radical 2. So this will be under simplify also, or rationalize. 11 over radical 6 radical 2. Okay. Same thing. This is a division problem. I have two terms in the denominator, so I'm going to use the conjugate technique. The conjugate of this two terms is the same two terms, but with the opposite sign in the middle. Right? Radical 6 minus radical 2, radical 6 plus radical 2. And remember, parentheses around everywhere. Okay, so 11 radical 6 plus 11 radical 2. And remember that in this case, we are foiling. The middle two terms will cancel. So you can go ahead and multiply all four terms, or you can just multiply the first and the first, and the second and the second. Okay, I'm going to do the whole multiplication, but then I'm going to show you that it's only necessary to do the first times the first, second times the second. So first times the first is radical 36. Radical 6 times radical 2 is radical 12, minus radical 2 times radical 6, minus radical 12, minus radical 2 times radical 2, minus radical 4. And notice again that the two middle terms cancel. So that's why it's when you use the conjugate technique, you only need to multiply the first times the first, second times the second. So 11 radical 6, 11 radical 2, this is 6, this is 2, 6 minus 2, 4. And that's my final answer. Okay. This is where we stop. There's nothing more that we can do here. So again, at the end, if your work is correct, this number here will not have a radical associated with it. So let's see the next one, 20.11. We can do 20.11, but 20.11 is similar to that. But in this case, we have two terms in the numerator. We can do that. So, which is a little bit more complicated than the other one. So a plus radical 3, a plus radical 3 over 6 minus radical 2. 6 minus radical 2. Again, division problem, I'm going to use the conjugate, and it's the conjugate of the denominator, not the numerator. So 6 plus radical 2 6 plus radical 2. Whatever it's written here, you're going to write it the same way, but with the different opposite sign in the middle. So minus, this becomes plus. Make sure you put parentheses all around. And now I am going to FOIL the numerator and I'm going to FOIL the denominator. Okay. So this is using the properties that we saw in the previous video, multiplication of multiple radicals. So 6 times 8, 48. 8 times radical 2, 8 radical 2. Radical 3 times 6, 6 radical 3, plus radical 3 times radical 2, radical 6. And remember, things inside of the radical multiply each other. Things outside of the radical multiply each other. Okay, so in the numerator, there's very little that we can do because nothing is a like radical. I cannot simplify anything. I cannot add anything. So the numerator is going to stay this way. But the denominator, because it's the conjugate, the two middle terms will cancel, and you are going to be left with these two products. So 6 times 6, minus radical 2 times radical 2, minus radical 4. Okay, and obviously this is 2. So my final answer will be 48 plus 8 radical 2 plus 6 radical 3 plus radical 6, 36 minus 2, 34. Okay, so normally if you could, you should be able to simplify by 2. This is simplifiable by 2. This is, but this isn't. So this is my final answer. Don't change anything else. Okay. 20.15 now. Take a look at 20.15. This is an important example. 20.15, 7 radical 3. Radical 7 minus radical 3. Radical 7 plus radical 3. Same as before, I have to look at the denominator and I'm going to use the technique of the conjugate because I have two terms. But remember, the conjugate is the opposite sign of this. It just so happens that the conjugate is the same as the numerator, which is perfectly fine. Okay. Numerator, I am going to FOIL both. Radical 7 times radical 7 is radical 49. Radical 7 times minus radical 3 minus radical 21. Minus radical 3 radical 7 minus radical 21. Minus radical 3 times minus radical 3 plus radical 9. Okay. Now for the denominator, remember, once we do the conjugate, if the same two terms are being multiplied, but they have opposite signs, you only need to do these two. Professor, why didn't we just do that for the numerator? Because the numerator both have the same sign. So this is only going to work if one is positive, the other is negative, and they have the exact same values as here. So you can do the 4, the two middle ones will cancel, or you can do just the first two. So radical 7 times radical 7 is radical 49. And then radical 3 times minus radical 3 minus radical 9. Okay, this is 7. This is 3. This is 7. This is 3. So I have 7. And be very careful here, extremely careful. What is negative radical 21 minus radical 21? Some people will write negative 42. This is very, very wrong. The answer to this is, there's an invisible one here, minus 2 radical 21 plus 3. 7 minus 3, 4. We're not quite done yet because I need to combine these two terms. 10 minus 2 radical 21 over 4. Now, this is very good. This is almost the answer. We're not quite there yet. Now, why not? Because that's why I said that sometimes these problems will be under simplify and not just rationalize. This answer needs to be simplified. Now, how do we simplify this? This is the correct way to simplify. I suggest you do the following. So simplify. I suggest you do the following. Split this in 2. N over 4 minus 2 radical 21 over 4. And now simplify each fraction. 5 over 2 by 2 minus divide by 2. I have radical 21 over 2. This is the final answer that we want. This is what a student normally would do. So this is correct. Okay. This on the right side would be incorrect. The student would look at the 2 and 4, simplify this by 2, simplify this by 2. And write this answer maybe. Or even worse, at this point, simplify this by 2, simplify this by 2, and get this answer. Now, notice that my answer, the correct one, is this. This is incorrect, and this is even more incorrect. So do not make the mistake of doing this. It happens all the time. This is the correct way of doing it. So I suggest you split it in 2 and then simplify each fraction as you see over here. This is the correct way. Okay, so this is the procedure to rationalize the denominator, as we saw here, whether you have a single term or in this case, as we have 2 terms. With the 2 terms, we'll employ the technique of conjugate, as you saw here. With the single term, we are just going to multiply numerator and denominator by the denominator. So at the end, whichever technique you're using, depending if you have 1 or 2 terms in your denominator, the denominator must not have any radicals in it.